This is the new version of the prototype robot, also called the Mark 7. First of all, the most important feature is the ability to tilt the robot, not only like in the previous version, where if the robot goes over some obstacle, it can tilt itself, so like a passive tilting or pitching, but we've also added these servo motors that are attached to the body of the robot and to the left and the right drive system. So now we can pitch up and down using these servos electronically through the controller. Just push the left joystick, and if you push the right joystick, it goes up. Sometime in the future we can implement like an auto level feature where we would just require an IMU unit which would give us the how pitched is the base, so that we can counter rotate it and keeping it leveled as it goes over obstacles and terrain. Let's take a closer look at how the mechanism works. You can see that the servo motor is rotating and the whole drive system stays in place. The same goes for the right side. It's a pretty simple mechanism and yet very effective. Another big update is that instead of having these front wheels, we only have drive wheels both in front and in the rear, and that means that we can either configure it as a front wheels drive, rear wheels drive, or all wheels drive. To be honest, it doesn't really make that much of a difference because we are still using tracks. So there are some really small advantages for going all wheels drive in this, and the biggest advantage is that the tracks are more tight and are being pulled not just by one wheel but both wheels, so from both the front and the rear, and that could theoretically help it cross some really difficult terrain and slightly increase the performance of going on a terrain or crossing obstacles. It would somehow more easily cross over some difficult terrain, but it's just a theory right now. We'll have to test it out. But as you can see, it's totally prepared. Right now I have it in the rear wheels drive, both sides, but you could just slam another timing belt like this in the front and it should work. The problem is that it seems that the timing belt is not tight enough, and maybe just there is not enough space in the mechanism, because for some reason it's quite worn out, or at least it seems. So maybe we'll just have to adjust some lengths to make it more tight. And of course there are many new features and updates. For example, this spring, which helps the wheels stay tight relative to each other, and that spring helps to it solves the problem of tracks derailing, well, combined with that we switched from this front wheel to basically drive wheel, and in this configuration with the spring, the derailing should completely stop. We'll have to see in the outdoor test. And for example, it's quite hard to see, but right here, yeah, right there, this really small component I designed, and it's actually really important. What it does is that it combines, or not combines, but links together shafts of both of these really huge big motors. I've done this to increase the stability of the robot and to lock the axis of the motors in one place. So if there is, so for example, if you accelerate really quickly, or maybe something hits the robot, or the robot drives into something just with, for example, one track, it helps to absorb the impact. And future plans, of course, include finally putting the battery in its rightful place right here, and also from the other side right here. So 2 batteries, and also increasing the voltage from 12 volts to 24 volts. It's still not enough because the motors are designed to work at 48 volts, but this should be just enough for our applications, and we can maybe build some bigger robot with the same motors but with a bigger base and bigger battery. Yeah, that would be hella cool. Maybe, like 5 wheels, something like a bigger, like a steel robot. And again, there are many problems with this version. For example, as I mentioned, the timing belt, it starts to wear out, or some of the components, I feel like they're a bit bending and not holding quite right in place. I feel like the whole robot is kind of falling in the middle because of the weight of the motors. It's falling like the middle of the base is collapsing, and this would be solved with, in the previous robot I had aluminum skeleton, yeah, that's how it's called, combined with stainless steel rebars. And but the problem is that the right here I designed it kinda the electronically tilting mechanism. It takes a lot of place, and I just completely, not like forgot, but didn't take into account this when designing the robot, and many of the parts of the aluminum skeleton that would have an impact of reducing the the base of the motor, the base of the robot collapsing, they wouldn't fit inside. So I will have to again redesign it, maybe try a bit. I wanna keep, because I really like this design. It's simple, it's easy, and it doesn't require a lot of maintenance. But I will have to make it more compact to really fit more reinforcements, because I can feel especially when the tracks are on, and especially if I want to make this timing belt also on this side tighter, it would definitely mess around with the axis, because it could like tilt in some direction, and we want to keep it straight. And to keep it straight, we need to somehow connect the whole axle, the whole axis. So the robot with a wheel, which is inside here, somehow make it even more connected to the base. For example, like right here, like I connected it with the ceramic bearings right there, and that's one side. Looks like I will have to install ceramic bearings somewhere here, because right now it is just holding here in the middle, and then right here around this, again around in the center of the axis where it's rotating. The motor is screwed to this wall, but it is not screwed tight enough, because if it was screwed tight enough, it wouldn't be able to move. It needs to be loose enough to be able to move and to be able to tilt. So these are some of the challenges that we will need to solve for the... Just getting distracted here, sorry. So these are some of the challenges that we will need to solve in the third version. In the meantime, I hope that the custom BMS chip arrives so that we can finally put the battery where it belongs. Anyway, thanks for watching this video. Don't forget to like the video if you like it. If you have any comments about what you like, what you don't like, maybe what would you like for me to add to the robots, some updates, or maybe some additional features or components, just let me know in the comments. I really appreciate it, guys. And don't forget to also look out. I'm planning on making a test in my garden and testing the whole robot, figuring out some problems, trying to solve them. Yeah, might be fun. So bye bye.